Okay, this is part 2 of naming of videos. And yes, I stayed on the same slide because I want to kind of tell you where we were last time. We're talking about polyatomic ions. And I gave you a bunch of names, but how do you know what the names are? Okay, for example, we were talking about carbonate with the ATE, which means more oxygens, only has 3, but sulfate down here with 4 oxygens is the ATE. So how do I know all this? Okay. Well, in your textbook, you have this table. It's table 2.6 in the textbook. I've marked out mercury 1 and peroxide because I'm not going to expect you to know those. I do expect you to know all of these, but not just these, okay? And I'm going to eliminate a whole bunch of you for you to memorize, but I do suggest using note cards at this point, okay? Because if you put Cn minus on one side and you need to know what this charge is and cyanide on the other, then you can go back and forth between the two. So how do we eliminate memorizing some of these? And a good number of them can be eliminated by knowing the rule of 7 for oxyanion. So oxyanion just means an anion that contains oxygen. Okay. So here you see the number 7. Okay. I've blacked out oxygen because, of course, oxygen bound with oxygen, still oxygen, and fluorine doesn't do this either. Okay. But if I ignore the fact that those two are blacked out, I also have 7 elements. 1, 2, 3, 4, 5, 6, 7. So not only does it make the shape of a 7, but it is 7 elements. It just so happens that these two don't form that. Okay? So we have what's called on the oxygen, okay, which is in green, blue-green, that 2 oxygens means it's an ITE ending. So when I had C, well, that one's not good. Okay. When I have NO2 minus, it is nitrite. And 3 oxygens is the 8. So NO3, also a negative 1. You notice that both nitrogens have a -1 charge. It's nitrate, ATE ending. Okay? So if it's one of these 5 elements, 7 if you count those two, these 5 elements, then 2 oxygens makes it ite, and 3 oxygens makes it 8. Otherwise, which color's down here? 2. The off the 7, okay, which I have, these are the most common ones: silicon, phosphorus, sulfur, selenium, or arsenic. But also these metals over here, Cr and Mn. 3 oxygens makes it ITE, and 4 oxygens make it ATE. So that's why SO3, also 2 minus, was sulfite with an ITE ending, and SO4, 2 minus, is SULFATE. Okay, so the ATE ending. All right. So basically, if it's not part of the 7, it doesn't have to be just one of these. Then it's 3 to make it ite and 4 to make it 8. Okay. So when I do that, I can take this table, and just because of that rule, I can eliminate all of those. All of those I just linked out. So carbonate. I've already showed you the chlorite, the chlorate, the chromate, nitrate, nitrate, phosphate, sulfite, sulfate are all eliminated. Okay, here's that hypo and per right here. Okay, those 4 right there. It's not just those 4. Okay, I can have, so there's the 4 with chlorine, but it also happens with BrO minus, which is hypobromite. Because bromine's on the 7, it takes 2 to make ite. So then I have BrO2, 2 minus, is bromite. BrO3, now still on the 7, oops, this is a minus. I can erase that. Minus is bromate. And BrO4 minus is perbromate. Okay, so those 4 do that. Also, I'm going to cheat here and just erase a little bit. So erase that and that, and this, and this, and this. So I don't have to write quite so much. That, and this. And I can have IO2 minus, oops, down there, IO3 minus, and IO4 minus. And you notice I didn't, this one I erased more than I should have. It's a hypoiodite. Oops, I should have erased the M too. And the M there. And the M there. And the M there. Okay. IO2 minus is simply iodite. IO3 is iodate. And IO4 is periodate. So the chlorines, the bromides, and the iodines follow this hypo and per. And so I've just expanded on that table in this table 2.6 by adding iodine and bromine to this. Okay. Now, so there's all those. And if I add hydrogen or dihydrogen to the name, then I can eliminate this hydrogen carbonate. So I take carbonate and I add a hydrogen to it. And hydrogen's a +1. So a -2 plus 1 gives me a -1. And that's what I have right here. I have monohydrogen phosphate because the phosphate is PO4 3-, so I can add 1 hydrogen, it becomes a 2-. I add 2 hydrogens by saying dihydrogen, and it becomes just a 1-. I have hydrogen sulfide, so all I did was I added hydrogen to this one, and I got this one. Again, it went from a 2- to a 1-. Or hydrogen sulfate, take this one and add a hydrogen to it. It goes from being a 2- to a 1-. So now, basically what I'm left with memorizing is ammonium cyanide, acetate, oxalate, dichromate. Okay, it still has the same charge as chromate, but it's different because it has the 2 and the 7 there. Permanganate kind of follows the rule. The reason I didn't eliminate that with the rule of 7 is because it's just a -1 charge. Hydroxide is an OH, and thiosulfate is S2O3. Okay, so these really don't follow any rule, so you still have to memorize those. Okay, and I do mean you have to memorize those because of the fact that they will come up. And I should have mentioned this earlier, but nomenclature is the one thing that's on every exam for the semester. Okay, so it is worth your time to put the effort in now because you will see this on every exam that you take in 12-11 this semester. Okay. So how do I apply these? Okay, so I look at calcium. Okay, calcium is right here on the periodic table. So the first thing I have to ask myself, is what kind of compound is this? Is this an ionic, molecular, or an acid? All the ones we're doing right now are ionic. Okay, but this is in 2A, so therefore it's a main group. So all I have to do is write calcium. Okay. There's only 2 atoms, so it means it's binary, so this is calcium oxide, because the oxygen becomes ide. So even though oxygens are all those oxy atoms, if it's just by itself without any other non-metal with it, it just is oxide. Okay, MnO2. Okay, so let me eliminate this one. All right, so Mn is right here on the periodic table. So first question, is it ionic, molecular, or an acid? Okay, well, it's ionic because this is a metal, okay, or cation. But second question, is this main group or is this transition plus? Okay, and so this is transition plus. The plus is over here. So transition plus are basically from here all the way down to here, although we don't know any of the new ones. That's okay. They're still technically plus. Okay, so this whole group here I call transition plus, meaning back to where we did the rules, it's rule 2 and rule 3. So anything that's in rule 2 or 3, so transition plus, you have to put the charge there. So I have to look at this. Okay, we did some of these in a couple of videos ago. The fact that the charges come from this. Okay, so oxygen is a 2 minus, so manganese must be a 3. So I have to say the fact that this is manganese. Oops. 3 oxide. And I forgot that parentheses there. Okay, so the transition pluses, I need to have this charge here. Okay, this one is divided here. Okay, so this is 2 polyatomic ions. NH4, you have to know, is ammonium. HCO3 is hydrogen. It's got the hydrogen there. Carbonate. Hydrogen. Can't spell and talk. Carbonate. So it's a really long name. I still can't spell. Okay, carbonate. Okay, and okay, so let me erase some of this stuff. Okay, Cu parentheses NO3 2. So Cu is copper. Okay, so it's also a transition plus. Okay, so I have to have the charge. Okay, so with nothing being written here, it's assumed to be a 1. And this is why I have to know what the charge is. So NO3 is a negative 1. So as long as those two match, they're fine. Okay, so that means that the 2 comes up here. So this is copper 2 nitrate. Okay, so I'm going to stop this video here and come back to this